Hello everyone, welcome to the presentation on efficient string shifting with difference array. In this presentation, we will explore how we can apply left and right shifts to a string efficiently using a technique called the difference array. Let's dive into the problem and the solution. Let's begin by understanding the problem. We are given a string of lowercase English letters and a 2D array of shifts. Each shift represents a range of indices and a direction, either left or right, to shift the letters in the string. The goal is to apply all these shifts and return the final string after all operations. This sounds simple, but we need an efficient way to handle multiple shifts across large strings. To solve this problem effectively, we will use a difference array approach. First, we will iterate through the shifts array and update a difference array based on the start, end, and direction of each shift. Then we will compute the cumulative shifts for each characters. Finally, we will adjust the characters in the string based on the cumulative shifts, ensuring that we wrap around from Z to A or vice versa as needed. Let's now understand how the difference array helps. Instead of applying shifts directly, which could be slow, we record changes in the difference array. For a shift from index start to end, we increment the start position and decrement the position just after end. This approach allows us to track all changes efficiently and compute the final result later. Once we have updated the difference array, we compute the cumulative shift for each character in the string. This is done by summing the values in the difference array. The cumulative shift tells us how much each character has shifted, and we handle wrapping around using modulo 26, ensuring that after Z we go back to A. Here's the beginning of the code implementation in C++. First, we initialize the difference array, then we loop through the shifts array to apply the differences at the appropriate indices. For each shift, we either increment or decrement the start and end positions of the shift. This will allow us to later calculate the cumulative shifts. After applying all the shifts to the difference array, we calculate the cumulative shifts for each character. This is done by iterating through the string and summing the values from the difference array. We store these cumulative shifts and use them to modify the string later. Finally, we apply the cumulative shifts to the string. For each character, we calculate the new position by adding the cumulative shift and using modulo 26 to ensure the alphabet wraps around. Negative shifts are handled by adding 26 before applying modulo. This ensures the shifts are applied correctly whether the shift is to the left or the right. To summarize the code, the difference array allows us to efficiently record the shifts. The cumulative shifts help us track the total shift for each character. Lastly, applying the shifts to the string is straightforward once we have the cumulative shifts, and modulo 26 ensures we handle the alphabet's circular nature. Let's walk through an example. Suppose the string is ABC and the shifts are 0, 1, 1, 1, 2, 0, 0, 2, 1. Initially the string is ABC. After the first shift, it becomes BBC. The second shift turns it into BAC, and finally the third shift results in ACE. So the final output is ACE. Let's now analyze the time complexity of the solution. Processing the shifts array takes big O of m, where m is the number of shifts. Calculating the cumulative shifts requires big O of n, where n is the length of the string. Applying the shifts also takes big O of n. Therefore, the overall time complexity is big O of m plus n, making this approach very efficient. The space complexity is big O of n due to the space used by the diff and cumulative shift arrays. To conclude, this method efficiently handles multiple shifts on a string using the difference array technique. By calculating the cumulative shifts and adjusting the string accordingly, we ensure that the solution is optimal and avoids unnecessary recalculations. This approach guarantees that we can handle even large strings and multiple shifts efficiently. Thank you for your attention. If you have any questions or need further clarification, feel free to ask. I am happy to answer your queries.